Hey guys, welcome to class. Today we're going to do lesson 4.3 where we will be linking some of the things that we've learned about greatest common factor and least common multiple to fractions and be making some connections here. So before we begin making those connections, we need to do a quick review of fractions. I'm going to talk to you about something that I am assuming you have seen and know before. And actually, our next unit is going to be all about fractions. So we're going to be diving into this deeper. But for right now, I'm going to start with just a quick review. And that is, we're going to talk about equivalent fractions. So two fractions that represent the same number or the same amount are what we call equivalent fractions. So the easiest way that I can remind you of this is where we could take two circles and split one in half and shade half of it. And so we all would say that's 1/2. Or we could take the same circle, split it into 4 pieces, shade 2 of those. And you hopefully notice here that we have shaded the same amount, that those two are two equal amounts, and therefore we would say 1/2 and 2/4 are equivalent fractions. So to find equivalent fractions, all we have to do is multiply or divide the numerator and the denominator. Remember, the numerator is the top number, the denominator is the bottom number, by the same number. Or what you will hear me say often is whatever we do to the bottom, we have to do to the top. And that is how we keep things equivalent, is by doing the same thing to the top and bottom. Okay, so let's go ahead and take the fraction 6/18 that they've given us here. And they say one way to get an equivalent fraction is to multiply the numerator and the denominator by 2. When I do that, I get 12 over 36, and so that would be an equivalent fraction. I could take that same fraction and I could divide the top or bottom by 3. When I do that, I end up with 2/6, which is another equivalent fraction. And so we could say that 12 over 36 or 2 over 6 are both equivalent fractions to 6/18. Now, what you should be thinking is there are definitely more equivalent fractions. We could have divided the top and bottom by 6. We could have divided the top and bottom by 2, and those would have all given us equivalent fractions as well. We also could have multiplied the top and bottom by different numbers. In fact, if you think about it, how many equivalent fractions would there be to this fraction 6/18? Well, hopefully you realize that there's an infinite amount, because you could multiply the top and bottom by 5, you could multiply the top and bottom by 100, you could multiply the top and bottom by 1,000, and we could just keep going and going and going, and so we have an infinite amount of equivalent fractions. Now, there's only a certain amount of things you could divide by, but there's an infinite amount of things that you could multiply by. All right, so let's do a little practice. Notice the directions say to write two fractions that are equivalent to the given fraction. And these directions will be the same in your homework, so just make sure that you do find 2. I'm going to ask that when possible, you try to find one by multiplying and one by dividing. And so I'm going to start on this first one, and you'll notice I can divide the top and bottom by 5. When I do that, I get 1/2, so there's one equivalent fraction. Then I'm going to start with 5/10 again, and I can multiply the top and bottom by anything I want. I'm going to go ahead and keep it easy for myself and just pick 2. And so 10/20 would be another equivalent fraction. Let's do another one. 6/9, I see that I can divide the top and bottom by 3. When I do that, I get 2/3, so there is one equivalent fraction. I could take 6/9, and this time, just to switch it up, I'm going to multiply the top and bottom by 10. You could still choose to multiply the top and bottom by 2, by 3, by 15, it doesn't matter. Just pick something easy. And so 60 over 90 would be another equivalent fraction. So why don't you pause the video real quick and try 3 and 4. All right, so go ahead and check your answers with mine, although do remember that you might not have gotten the same thing I did. I, on Number 3, divided the top and bottom by 2. You could have divided the top and bottom by 4. You would have gotten 3/5 then, which would also be equivalent. I multiplied the top and bottom by 2. You could have chosen something totally different. So remember, there's an infinite amount of correct answers. Now, there are answers that are wrong if you multiply wrong or divide wrong, but there are an infinite amount of correct answers. Okay, so now that we have an understanding of equivalent fractions, we're going to start applying this to greatest common factor. All right, so a fraction is in what we call simplest form. I'm guessing you've maybe heard that word before. When its numerator and denominator are relatively prime. Now let's remember what that word means. We talked about relatively prime when we talked about GCF. Two numbers are relatively prime if their GCF is 1. In other words, they have nothing in common. They have no common factor except 1. Okay, so let me just give you a quick example here with an easy fraction. If we had the fraction 3/6, we would say this is not in simplest form. The reason it's not in simplest form is 3 and 6 have a common factor. They have the factor of 3, so they're not relatively prime. That's not in simplest form. Now we could write an equivalent fraction to this that is in simplest form. That would be 1/2, and we know that that's in simplest form because 1 and 2 have no common factor except for 1. Okay, so to write a fraction in simplest form, all we have to do is divide the numerator and the denominator by their GCF, or their greatest common factor. Now here's the deal. You've probably done some stuff with fractions before, and if I gave you a fraction as simple as 3/6, that's really easy for you, I would hope, to simplify that to 1/2. However, we're going to be getting into more complicated fractions with bigger numbers, or if you look at 3 and 4 down below here, fractions that have not only numbers but also variables. And so this trick that I'm about to teach you and this connection we're about to make is going to be really, really helpful. Because what we can do is find the numbers GCF, which we've gotten really good at doing, and then if we divide out or cancel out the GCF, what we're left with is the fraction in simplest form. Let me show you what I mean, and I do want you to do it this way on these as we're getting used to this new method. Okay, so the first thing I need to do is find the prime factorization of the numbers I've been given. So in this case, that's 27. Which can break into 3 and 9, and then 9 into 3 and 3. So I'm going to write this as 3 times 3 times 3. And then 42, I can break into 6 and 7. 7's prime, and that goes into 2 and 3. So again, remember I always write in order from least to greatest. Okay, so this should look really familiar to you. We are just finding the prime factorizations of those. Then I'm going to find what they have in common, just like I've been doing. And I notice here that they have a 3 in common. So what I know here is that their GCF is 3. There's nothing else they have in common. Well, if I cancel out that GCF, or in other words, divide out that GCF, then on the top, I'm left with 3 times 3, that's 9. On the bottom, I've left with 2 times 7, that's 14. There's the fraction in simplest form. Kind of cool, huh? All right, let me do another example for you. Okay, so I will take 28 here. I'm going to divide this into 4 and 7. 7's prime, so I'm going to break the 4 into 2 and 2. So 28 is 2 times 2 times 7. Then 49 breaks into just 7 times 7. Okay. So then I'm going to highlight what they have in common, which again in this one they just have one thing in common, and so the GCF here would be 7, and I will tell you on your homework you will have to identify the GCF and the fraction in simplest form. All right, so if I get rid of what they have in common, that GCF, if I divide it out, on the top I'm left with 2 times 2, which is 4. On the bottom, I just have 7. So there is my simplified fraction. Now, I do realize on these first two examples, these weren't massive numbers. They weren't terribly difficult. You might have been able to do it without this method, but I want you to start seeing how this works, because let's now zoom in and do number 3, which is a much more complicated problem here. Okay, so We've already factored monomials. We've gotten pretty good at that. So let's go ahead and start by factoring these. So 9 I can break into 3 and 3. So this is going to be 3 times x times y times y. Again, I break that into all of its pieces, okay? Then 24 can break into 6 and 4, or there's obviously a variety of ways you can do that. I'm going to keep going till I hit prime numbers. So 24 is 2 times 2 times 2 times 3. Then I have times x times y times y times y. That's a long one on the bottom. All right, the next thing I'm doing is looking at what they have in common. These have a 3 in common, an x in common, and 2 y's in common. Okay. So just like I did up there, that's what I need to get rid of is that GCF. So I see here that the GCF is 3xy squared. That's what I need to divide out. As soon as I divide that out, now I can see what I have left over. So on the top, I have just a 3 left. On the bottom, I have 2 times 2 times 2, that's 8, and 1x and 1y. So there is your simplified fraction, 3 over xy. And you can see how that would be complicated to have to break down on your own, but once you can break it into all of its prime pieces, get rid of what they have in common, then all you have to do is see what they have left over. All right, so I'm going to ask you to pause the video right now, and I want you to try number 4. All right, so let's check how we're doing so far. You break 18m to the 3rd power and 30mn into all of their pieces, and hopefully what you see is that they have a 2, a 3, an m, and an n in common. So I know that their GCF is 6mn. If I get rid of those, or cancel out or divide out the GCF, then what I'm left with is 3n to the 2nd power in the numerator and 5 in the denominator. And there is your simplified fraction. All right, now let's move on and talk about the relationship that we can see how least common multiple can help us with fractions. All right, so the least common denominator of 2 or more fractions is simply the least common multiple of the denominators. Now, if you've had some experience with fractions, you know that there are multiple times where we need to find a common denominator. We definitely need to have a common denominator whenever we add or subtract. We'll talk about that in greater detail in a future lesson. But we also need common denominators when we're comparing fractions. For example, if you look at this first example that I've given you here, 5/6 and 7/9. Well, it's a little hard to tell which of those fractions is bigger because our pieces are not broken into the same size pieces. And so before we can compare them, we need the denominators, which tell us how many pieces something's broken into, to be the same. And so to do that, all we have to do is find the LCM, or the least common multiple, of these two denominators. And so again, this is a skill we've hopefully gotten pretty good at. I'm going to break each of these into their prime factors. So 6 is 2 times 3, 9 is 3 times 3. Then I'm going to group what they have in common, which I can see here that they have a 3 in common. So remember, for LCM, we take what they have in common and then also what they have left over to multiply. And we see here that 18 is the least common multiple. So what I'm going to do is, using this idea of equivalent fractions, I am going to rewrite both of these fractions to have a denominator of 18. So then it's easier for me to compare them because they're broken into the same size pieces. So here's this thing of equivalent fractions that we worked on in the beginning of the lesson. And I see here that if I multiply 6 by 3, I get to 18. And so we talked about with equivalent fractions, whatever you do to the bottom, you have to do to the top. So I'm going to multiply the top by 3 as well to keep it equivalent. On the bottom fraction there, I see that 9 I have to multiply by 2. So then again, I need to multiply by 2 on the top. Now, you can see here how close these two fractions were. One of them is 15/18, one of them is 14/18. Now, when they're broken into the same size pieces of 18, it's much easier for me to see that the fraction 5/6 is bigger. And so you can just simply write your answer as an inequality if you would like. So 5/6 is greater than 7/9, going back to those original fractions that they asked me about. Or you could write a sentence that said 5/6 is the greater fraction. I think it's easier just to write an inequality, but it's up to you. All right, so let's try another one now. I'm going to break 8 into its prime factorization. So that's just 2 times 2 times 2. I can also break 20 down. And again, there's multiple ways to do that as we keep talking about. That's 2 times 2 times 5. Now I'm looking what they have in common, which is they each have 2 2's. So when I find their LCM, I take what they have in common, which is a 2 and a 2, what they have left over, which is another 2 and a 5. So this is 8 times 5, which is 40. So now what I'm going to do is I'm going to take both of these fractions and write them with the common denominator of 40, because again, it's much easier for me to compare if I'm comparing things that are broken into the same size pieces. So I know that I need to multiply 8 by 5 to get to 40. So because of equivalent fractions, whatever you do to the bottom, you have to do to the top. You get 25 over 40. Bottom here, if I multiply 20 by 2, then I have to do the same thing to the top. All right, and again, you can see that these two were really close in size, but it's much easier for me to compare when they have the same common denominator. So in this case, I can see that 13 out of 20 is greater than that 5/8 fraction. All right, so why don't you now pause the video and try this on your own? I'd like you most specifically to try 3. If you have time before we play the video again, you're welcome to try 4 as well, but try to get at least 3 done here. And again, I want you to show the work of finding the least common multiple, then writing both fractions with that amount. All right, so go ahead and check your answer here. Hopefully you found that between 12 and 15, the least common multiple is 60. They have a 3 in common, then a 2 and a 2 and a 5 left over. So then I rewrote both fractions to have that common denominator of 60. And once I did that, I can compare and see that 11/15 is greater than 7/12. All right, let's try one last example where we are comparing 3 different fractions instead of just 2. The steps are really similar, except now we're obviously going to have 3 numbers that we're dealing with. Okay, so first of all, let's go ahead and make sure that all of these are improper fractions as opposed to mixed numbers. You see that first one there is a mixed number. So just a quick review, when you're changing something from a mixed number to an improper fraction, 4 and 5/12 means we have 4 wholes of 12 out of 12. So we can do 4 times 12, which is 48, and then add that 5 to get 53 out of 12. Then we have the 9 over 2 and the 33 over 8. So I'm going to go ahead and I'm going to take those 3 denominators and find the least common multiple of them. 2's already prime, obviously. All right, so 12 is 2 times 2 times 3. 2 is just 2. And then 8 is 2 times 2 times 2. So now I'm going to group what they have in common. So they all have a 2 in common. And then remember, for LCM, we can also group things that are only in 2 of the rows. So we can group another one of those 2's. So now for the LCM, I'm going to take what they have in common, which is a 2 and a 2, and then the leftovers, another 2 and a 3. And so I see that the LCM is 24. So then, just like I've done on these previous ones, I'm going to take all of these fractions, and I need to write equivalent fractions that have a denominator of 24 so that it's easier for me to compare. All right, so in that first one, I see that I can multiply the top and bottom by 2. In the second one, I'm going to multiply the top and bottom by 12. And in the last one, I'm going to multiply the top and bottom by 3. Okay, so 53 times 2 is 106. 9 times 12 is 108. And then 33 times 3 is 99. So now it is much easier for me to compare and put these in order from least to greatest. So I'm just going to make my list here. The smallest one is 33 out of 8. The next smallest one is that 4 and 5/12, which I had turned into 53 over 12. And the biggest one is 9 over 2. And so again, just like when you were comparing 2 fractions, you can also compare 3 or even more fractions. All you have to do is change all of those denominators to be the same so that you have equal size pieces that you are comparing. All right, so hopefully this helped you see some connections, how greatest common factor and least common multiple can help us solve some fraction problems. Have a great day.